Hello students, this is our first lecture on graph theory. Graph theory is a branch of applied mathematics. In this video, we are going to discuss about basic concepts in graph theory. So first concept is vertex. Vertex is the fundamental or basic unit of a graph. There are three ways to represent a graph. This is first way. V is label or name of this vertex. This is second way and this is third way. Next unit is edge. Edge is a line segment joining any two vertices of graph G. We are not familiar with graph, but we are familiar with vertex. So suppose A is a vertex and B is another vertex. A line segment joining A and B is called as an edge. I am naming this edge as E. Now this is vertex U and this is vertex V. A line segment joining U and V is also an edge. We are calling this edge as F. E can be written as E is equal to AB. A and B are end vertices of edge E. So we can write E as AB. Similarly, U and V are end vertices of edge F. So we can write F as UV. Now we are familiar with concept vertex and edge. So now we can define graph. What is graph? Graph G. We usually represent graph by letter G. Graph G is an order pair VE where V is a set of vertices and E is a set of edges. So combining vertices and edges combiningly called as graph. So suppose A is a vertex, this is second vertex B and this is third vertex C, edge BC, edge AC and edge AB. So this triangular shape is a graph because it is a combination of vertices and edges. I have called AB, edge AB as E, AC as F and BC as G. So this is a graph G, or we can write G as G 3, 3, where this order pair 3, 3 represents number of vertices and number of edges in graph G respectively. In this graph, there are three vertices. So first three represent number of vertices and second three represent number of edges. For this graph G, vertex set of G denoted as V or V of G is equal to ABC. Here three vertices ABC are present in graph G. So we have written vertex set of G as A, B, C. And there are three edges EFG in graph G. So we can write edge set of G as E or E of G is equal to EFG. We can represent edge E as AB. So I have written E as AB, F is equal to AC and G is equal to BC. So we can write E in two different forms as EFG or AB, AC and BC. Next concept is degree of a vertex. Now we are familiar with what is vertex, what is edge and what is a graph. So number of edges incident on any vertex is called as degree of vertex. We will see an example. So now I am drawing a graph with vertices A, B, C, D and E, F. First edge is AB. We have called this as E1. Second edge is BE. We have called this edge as E2. Next is BD. Now I am labeling these edges and drawing a graph. So this is our graph G. So now what is degree of a vertex? So see vertex A. Vertex A has only one edge E1 incident on A. So degree of A is 1. Now consider B. There are four edges E1, E2, E3 and E4 incident on vertex B. Therefore, degree of B is equal to 4. Similarly, we can count degree of C, D, E and F. So for C, there are three edges incident on C. First edge is E4, second edge is E8 and third edge is E5. So degree of C is equal to 3. Next vertex D, there are 3 edges incident on D, E5, E3 and E6. Therefore degree of D is also 3. If you count number of edges incident on edge E, it will be 3, and these 3 edges are E6, E2 and E7. Therefore degree of E is also 3. And for vertex F, there are 2 edges incident on F, E7 and E8. Therefore degree of F is equal to 2. Now next concept is types of vertices. Depending on degree of each vertex, there are 3 types of vertices. First vertex is even vertex, second vertex is odd vertex, and third vertex is pendant vertex. So even vertex is a vertex whose degree is an even number. Odd vertex is a vertex whose degree is an odd number, and pendant vertex is a vertex whose degree is 1. So if you consider vertex A, then A has degree 1. Already we have discussed how to count the degree of vertices. So there is only one edge E1 is incident on vertex A. Thus A is a vertex with degree 1, and vertex with degree 1 is called as pendant vertex. Thus A is a pendant vertex. B has degree 4 and 4 is an even number. Thus B is a even vertex. Degree of C is 3. 3 is an odd number. So C is odd vertex. Degree of D is equal to 3, which is also an odd number. So D is also a odd vertex. For E, degree is 3. Similar to C and D, E is also an odd vertex. And F, degree of F is 2. 2 is even number. So F is even vertex. Adjacent vertices. So two vertices are said to be adjacent if there is an edge between them. So this is our graph. So we will see pair of adjacent vertices and pair of non-adjacent vertices. So there is an edge between vertices A and B. So A and B are adjacent vertices. Similarly, there is an edge between B and C. So B and C are also adjacent vertices. C and D, there is an edge between C and D which is E5. So C and D are also adjacent vertices. D and E are adjacent vertices because there is an edge between D and E. E, F are also adjacent as there is an edge between E and F. Similarly, F and C. Now let us see pair of non-adjacent vertices. If there is no edge between any two vertices, then we call those two vertices are non-adjacent. So first example is A and F. You can easily see that there is no edge between A and F. So AF is a pair of non-adjacent vertices. B and E. Actually B and E is not pair of non-adjacent vertices. By mistake I have written here. But B and F is a pair of non-adjacent vertices. D and F is a pair of non-adjacent vertices because there is no edge between D and F. So in short, if there is an edge between two vertices, then we call those two vertices adjacent, and if there is no edge between two vertices, then we call those two vertices are non-adjacent. Now next concept is adjacent edges. So if there is a common edge, common vertex between two or more edges, then we call those two edges are adjacent. So let us see which edges are adjacent and which edges are not adjacent. So if you consider edges E1, E2, E3, E4, then B is a common vertex to them. E1, E2, E3, E4, you can observe B is a common vertex to them. So E1, E2, E3, E4 are pair of adjacent edges. Similarly, E4, E5 and E8, C is a common vertex between E4, E5 and E8. Thus, these three edges are adjacent edges. E7, E8. E7 and E8 have common vertex F. So these are adjacent edges. Now next concept is self loop. What is self loop? If an edge has same initial and terminal vertex, then we call that edge as self loop. So here I have drawn a graph with vertices A, B and C. Edge between AB is E1, edge between BC is E2, and this is an edge E3. You may easily see that C is a vertex where E3 is incident on C. That means E has only one vertex C. E3 has only one vertex C. That means E3 has same initial vertex and same terminal vertex, that is C. Thus E3 is a self loop. Next concept is parallel edges. If two or more edges have same initial vertex and same terminal vertex, then we call those edges are parallel edges. So let us see this graph. So if you observe edges, so we will give names to these edges: E1, E2, E3, E4, E5 and E6. So E1 and E2, these are edges incident on AB. E1 has end vertices AB and E2 has also end vertices AB. So E1, E2 is a pair of parallel edges. Similarly, E5 and E6. E5 has end vertices DE and E6 has also end vertices D and E. So E5 and E6 is also a pair of parallel edges. That means in this graph we have two pair of parallel edges. First pair is E1, E2 and second pair is E5, E6. Next concept is simple graph. So a graph without any self loop or parallel edge is called as simple graph. That means a graph should have no self loop and no parallel edges. So let us draw this graph with vertices A, B, C, D and E. This is the same graph we have discussed earlier, and this is second graph. So if you consider first graph has parallel edges E1, E2 and E5, E6. So first graph is not a simple graph because definition of simple graph is a graph without any self loop and parallel edges. That means that a graph should not contain self loop as well as it should not contain parallel edges. And if you observe second graph has no self loop and no parallel edges. So second graph is a simple graph. In our entire syllabus, we are going to discuss about simple graph. So in this video, we are familiar with vertex, edge, graph and simple graph. In our next video, we are going to discuss about further concepts. Thank you. Thank you.